This question says that with respect to region O, the position vectors of A and B are given by this and this. Find the vector equation of the line passing through AB. Okay, easy peasy. R equals, use any one of the coordinate, either A or B. If I'm using A here, 1, 2, minus 1, then I'll write plus lambda. And in the other bracket, I'll have to do B minus A, which is 0, 3, 1, minus 1, minus 2, and minus 1 will become plus 1. So R equals 1, 2, minus 1 plus lambda minus 1, 1, and 2. So R equals I plus 2j minus k plus lambda minus I plus j plus 2k. Part B. The point C lies on L and is such that AC equals 3 times AB. Find the position vector of C. Okay. So the point C lies on L. So point C lies on this vector line. That means OC will be equals to 1 minus lambda, 2 plus lambda, and minus 1 plus 2 lambda, since it lies on the same line. Okay, I just noticed a mistake in this question. I actually typed the same question from the past papers, but in the actual past papers, this vector symbol is not there. So we are going to ignore it. All right, now they're telling us that the point C lies on the line AB. So AB vector line we had already found, and C lies somewhere on this line such that AC is equals to 3 times of AB. So it's somewhere on this line. All right, maybe somewhere far away from here, so that AC is thrice the distance of AB. But anyway, since C lies on the same vector line, so now you can imply that the vector AC is equals to 3 times the vector AB, because C lies on the same vector line. So now, instead of using this to find the position vector, we're going to break this into the difference of their position vectors. OC minus OA equals 3 times OB minus OA. So we need to make OC the subject. OC minus OA is 1, 2, minus 1 is equals to 3 times B minus A we already did here, which was this, negative 1, 1, 2. So this becomes minus 3, 3, 6, and then plus 1, 2, 1. Sorry, 1, 2, negative 1, which gives us a negative 2, a 5, and another 5. Okay, now we write it as a position vector. So we can write OC equals minus 2I plus 5J plus 5K. Okay. Part C, find the possible position vectors of the point P on L such that OP is equals to square root of 14. All right, now that OP lies on the same vector line, we're going to write OP equals this. So since OP lies on this vector line, we're going to write OP equals this. And we're told its magnitude is equals to square root of 14. Since it says OP equals square root of 14, that means they're telling us about the magnitude of OP, which will be square root of 1 minus lambda squared plus 2 plus lambda squared plus negative 1 plus 2 lambda squared equals to square root of 14. We'll start by squaring both the sides and getting rid of the square root symbol. Okay. So now we're going to apply the identities a minus b whole square and a plus b whole square will become 1 minus 2 lambda plus lambda square plus 4 lambda plus lambda square plus 1 plus 4 lambda plus 4 lambda square equals to 14. 4, 5, 6, 6 lambda square, and then 4, 4, 8 minus 2 would be plus 6 lambda, and then 1 plus 4 plus 1 is a 6. 6 minus 14 is a minus 8 is equals to 0. So I'm getting 2 lambda squared plus 3 lambda squared plus 3 lambda minus 4 is equals to 0. So we will be solving this quadratic equation next. Okay, there seems to be a mistake here. Let me just try to find it because it should have been 3 lambda square minus lambda minus 4. So let me see what went wrong. There's a blunder here. This was supposed to be a square minus 2ab plus b square. So I miswrote this as a plus. Hence, my answer was not correct. So now we will get minus 2 lambda in the middle. This would be minus 2 lambda. And then in the next step, it will become minus lambda. Okay, so 3 lambda square minus 4 3 lambda square minus lambda minus 4 is the quadratic equation. Now we solve this using middle term breaking. So we can write 3 lambda square minus 4 lambda plus 3 lambda minus 4 is equals to 0. 3 lambda, lambda common. 3 lambda minus 4 plus 1 common 3 lambda minus 4 equals to 0. So 3 lambda minus 4 in a bracket, lambda plus 1 in a bracket equals 0. So we get lambda equals 4 over 3 and lambda equals negative 1. The question was find the find the possible position vectors of P. So OP is already there with us at the start. This now replace the lambda with the values found and get the two position vectors. Okay, so when lambda is negative 1, then OP is 2, 1, and minus 3. And when lambda is the other value, which is 4 over 3, we will get OP equals minus 1 by 3, minus 10 by 3, and 5 by 3. Now write these as column vectors. Write these as position vectors 2i plus j minus 3k and OP equals minus 1 by 3i minus 10 by 3j plus 5 by 3k.